Product of powers, when you're multiplying the same base, you add the exponents. Power of a power, when you have a power being raised to another power, you multiply the exponents. Product of a power, there are two things on the inside being multiplied, and so that means that you're going to distribute that m onto everything on the inside. A to the m times b to the m. Negative exponents, you can never leave an answer with a negative exponent. Never. When you have a negative exponent, a to the negative m is in the numerator. You can change the sign of your exponent by putting it in the denominator. If you start in the denominator and it's a negative exponent, then you would move it to the numerator. That is the rule for exponents. You can move back and forth between the numerator and the denominator. You just need to change the sign when you move from the numerator to the denominator, or vice versa. Zero exponent, anything to the zero power is 1. Quotient, well, if multiplying exponents means that you add exponents, what do you think you're going to do when you're dividing like bases? You are going to subtract exponents, which is kind of the same as the negative exponent. I have a to the n in the denominator, and I can bring that up to the numerator and have a to the negative n. So we change the sign of the exponent if you're moving between numerator and denominator. But the short and sweet of the quotient rule is to subtract exponents. The power of a quotient is the same power of a product. If there are whatever's on the inside of the parentheses, whether it's a product or a quotient, you're going to raise both of those to the power. So that would be a to the m divided by b to the m. And b cannot be 0. That would make it undefined. Same here, a cannot be 0. It would be undefined. There are many different ways to apply these. Not everybody's going to apply them in the same order. We have -4 times 2 to the 5th, and all of this is being raised to the second power. So you just rewrite it, having both of these terms being raised to the second power. So that would be -4 in parentheses. The 4 is also included in being squared, times 2 to the 5th being raised to the second power. And now you evaluate. We have -4 squared, which is 16, times, here we have 2 to the 5th being raised to the second. That is a power being raised to another power. If you look at the rules, it says that a power being raised to the power, you multiply those exponents. That would be 2 to the 5 times 2, which is 10. In order to combine these together, I need to have the same base, and I do not. Can I write 16 with a base of 2? 2 to the what power equals 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th times 2 to the 10th. Now I have like bases, and I can just add my exponents. I'm multiplying like bases. The base is 2, and then I add the exponents. 4 plus 10 is 14. Here I see that I have a negative exponent. How do I change negative exponents? I could put all of this in the denominator, or I could start by applying each one of these a power raised to a power. So again, there are many different ways to approach the problem. You try to use the easiest, shortest way, but it's not always possible to see that. Let's go. And now I need to combine these. They're like bases. I want to move the term. I want to move the exponent that's going to give me a positive exponent. If I bring the -5 down here, it will be +5. And -8 plus 5 is still a -3. So I don't want to move 11 to the -5th down to the denominator. I would like to move 11 to the -8 up to the numerator. That will be 11 to the -5 times, I'm bringing 11 to the negative 8 to the numerator. So to go between numerator and denominator, I change the sign of the exponent. That becomes 11 to the positive 8. Now I am multiplying with like bases. So when you're multiplying like bases, you add the exponents. Negative 5 plus 8 is going to be 11 to the third power. Example 2, scientific notation. We can use the exponent rules with scientific notation. A swarm of locusts may contain as many as 85 million locusts per square kilometer and cover an area of 1,200 square kilometers. About how many locusts are in such a swarm? The number of locusts would be 85 million times 1,200. So we have 85 million times 1,200. We are going to change this to scientific notation, which means we need to move the decimal until it's in the ones place. All we have is one term, so that would be 8.5 times 10 to the 367 times 1.2 times 10 to the 123. All right. Now we are seeing where we have some like bases here, 10 to the 7th times 10 to the 3rd. And we need to multiply 8.5 times 1.2. So this can be rewritten as 8.5 times 1.2 times 10 to the 7th times 10 to the 3rd. We have like bases here. When we have like bases, we need to add the exponents. So that would be 10 to the 10. And then we need to do 8.5 times 1.2. 10.2. Notice that this is still not in scientific notation. I need to move the decimal one more time. My final answer is going to be 1.02 times 10. I just moved it once, which means I need to have 10 to the 11th. Scientific notation can be used with multiplying and dividing, and a power to a power. You will see that in the homework. Example 3, we are multiplying and we have like bases. What do? We add up the exponents. We have 6 minus 4, which is 2, plus 7 is 9, b to the 9. We have a quotient being raised to a power. I am going to apply the exponent to the numerator and denominator. We get r to the negative 2 being raised to the negative 3 divided by s to the third power also being raised to the negative 3. Simplify. We have a power raised to a power, which means we multiply those exponents. So we get r to the negative 2 times negative 3 is positive 6. And then we have s being a power raised to another power. 3 times negative 3 is negative 9. We cannot leave negative exponents. The r to the 6th, there's nothing wrong with that, but here's my problem, s to the negative 9. I'm going to shift s to the negative 9 to the numerator. So we get r to the 6th and s to the, you change the sign of the exponent. If it's negative 9 in the denominator, it will be positive 9 in the numerator. Final answer. Example C, we have a number, 16 divided by 2. We have an m in the numerator and nothing for m in the denominator, and then we have an n in the numerator and the denominator. So one piece at a time. We have 16 divided by 2 is 8. Takes care of that. M to the fourth, there's nothing happening with that. And then we have n to the negative 5 and n to the negative 5. It doesn't matter which way you move it, it's going to cancel, but I'm going to show the work for that. I'm going to bring n to the negative 5 to the numerator. So I already have n to the negative 5. And when I bring n to the negative 5 to the numerator, it changes the sign. It becomes positive 5. Now I have 8m to the fourth. And then I have n to the negative 5 times n to the 5. You add your exponents and you get n to the 0. Final answer? Anything to the 0 power is 1. So that's 1 times 8 times m to the 4th. Eight m to the 4th. And again, I could have just canceled them here. Anything over itself is going to cancel, but I wanted to show you some things that you might run into in the homework. Last example, example 4. We have a numerator that's being raised to a power, so I'm going to apply that first. X to the negative 3 is being raised to the second times y to the 3, also being raised to the second, and we have x to the 5th, y to the 6th. Next, I'm going to take care of power to a power. When we have a power being raised to a power, we multiply those exponents. So we get x to the negative 3 times 2, and then we have y to the 3rd raised to the 2nd. So that would be y to the 3 times 2, which is 6. And we still have x to the 5th and y to the 6th. All right, so we have some x terms to combine together, and we have some y terms to combine together. If I move my 5 to the numerator, that's going to be negative 5, and that means I'll have a negative exponent. The rule of thumb is that you bring the smaller exponent to the larger exponent. Negative 6 is smaller than 5. I'm going to bring x to the negative 6 into the denominator. We have x to the 5th, and then x to the positive 6th. Here I see y to the 6th divided by y to the 6th. Those will cancel. Same situation that we had up top where we had, it would end up going y to the 0, and then that would just be 1. So we can just cancel those here. That leaves a 1 in the numerator, and I just need to finish the product here in the denominator. 1 over x to the like bases, you add exponents.